Okay, so today's video is going to be about it's going to be about solar system. Okay, in solar system we will be talking about the planets, asteroids, and even we'll talk about some uh, nature of planets. Nature of planets. By nature, I mean what they are made of. Main concepts. Even more, well, I have not displayed more, but we will cover more as well. I don't think so. This is necessary because I always like to go off like connect every single topic with each other and like make a link. I like always like to make a link. Okay, so first of all, let's talk about the planets. Planets, first of all, in our solar system, there are not nine, 8 planets. How many planets are there? 8 planets. Starting from this guy to the least guy, and there are in between as well. Okay. Sorry, why am I using black on black? This one over here is the last one, which is Neptune, and this one over here is Mars. Not Mars, sorry, Mercury. I always get confused between them. It's staying with me. Okay, so know that uh, the first 4 planets in our solar system are known as rocky planets. Rocky planets. And the last 4 are gassy planets. Gas planets. Gas is bad. Planets. Okay. What I mean by rocky and gas is that what was it that rocky planets are, wait, how do I define it? Rocky planets would be defined as, how can I say it in simple terms? Okay, wait, I'll get on to it. Wait, let's define it in this way. Let's define how I can define is that. But before defining them, let's talk about something extra. The other 2 concepts we were talking about. Asteroids. We know that asteroids are what? They are rocks or like some kind of meteors which move in the solar system or in the universe. Asteroids, what were, and there's one fact about asteroids, that they have eyes. Asteroids or comets, I think it was comets, not asteroids, comets, they have uh, eyes. Like, they have literal eyes. I remember it from a series. Yeah. And one more thing, that the tail tail of comets, one comet that is orbiting our sun, Halley's comet, Halley's comet, which orbits our sun, like in this pattern. If I let me illustrate at like what the pattern that Halley's comet follow. This is our sun, and you will be shocked by the orbit Halley's planet is having. Look at that. This is the orbit Halley's orbit Halley's Halley's comet follow, or is on the path it does. And this is like about years journey, years of journey. And as we are on it, let's just talk about the energies. Here, when it's the furthest from the sun, it has its GPE is the highest, and when it's closest to the sun, its GP or its K dot E is the highest. It's opposite. Further, more GPE, less kinetic. Closer, more kinetic, less GPE. Okay, and this is how we call this an elliptical pattern. Elliptical orbit. Let me tell you what elliptical means. You might have heard of, or we know from since when we were in grade 2, 3, and when we started learning about solar system, we always knew that we were told that the conventional system, solar system, okay, so this is our conventional theory, conventional solar system. This is our sun, okay, and let me just make perfect circles. This is what conventional solar systems say. Okay, one more thing before doing that. The points where this point over here, this point has a special name. It is known as perihelion. Perihelion. aphelion, and the other one, which is away from the sun, furthest from the sun, is known as aphelion. If I'm wrong on spelling, I'm sorry. Aphelion. Okay, so they're just 2 points. If you want to know that, it's fine. This is the conventional way solar systems are described in our textbooks, that the planets orbiting the sun have perfect orbit. Okay, this is wrong. We know that according to Kepler's law, if this is an orbit, which is known as, this is an orbit, wait, I'm very bad at making an oval. Yeah, this is, if this is an orbit, and this orbit is known as elliptical orbit, elliptical this is the actual orbit. The orbit is actually like this, known as elliptical orbit, and according to Kepler's law, there are two foci on the in this orbit, foci 1, foci 2, and wait, let me get it wrong with corrective with, and according to Kepler, sun is on one of the foci. According to Kepler first law, Kepler, the sun is on one of the foci. Okay, and this planet, a planet over here, or what, planet on this is orbiting. The revolution. Okay, so this is what, and this, what this perfect, not perfect circle, elliptical circle, this is no, there's a special name for it, and the name for it was eccentricity. Yes, it's known as eccentricity. I remember now. Yes, eccentricity. The more it's eccentricity. So to define eccentricity, we could say this is a circle, this, wait, sorry, over here, so if I rank it from 1 to 0. This is the furthest. This is near 1. If it's near 1, it will be more elliptical than more perfect. This is a full one. This is full one. This near, we can, I'm just saying, the more it's closer to 1, the more elliptical it is, the more it's closer to 0, the more perfect circle it is. 1 closer to 1 means more elliptical elliptical closer to 0 is more perfect circle. Okay, yeah, over here. So, and now you must be wondering, if this is the case, what is the elliptical pattern of elliptical eccentricity of this comet, right? Now to break it to you, the comet is eccentricity is 0.97 eccentricity. This is the eccentricity of the Halley's comet. How much? 0.97 or 967, which is also rounds off to say 967. This is what eccentricity, how much eccentricity it has, which is near 1, which means it's more elliptical than more perfect circle. So, then Kepler's second law of Kepler. What does second law of Kepler say? Second law of Kepler says that for this, let's get a little imperfect. Let's suppose this is our sun. Oval. This sun on this point, and this is the planet orbiting. Okay, and moves here, 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 and here. So, second law states that what did I just make? The second law states that duplicate, bring here. Second law states that the point, this point, this point, wait, please let me be perfect. This point, when planet travels from here till here, the distance it covered within certain time, this distance A is equal to, let's suppose I say is equal A1. This distance equal, if the same planet covers from here till here, this distance covered in certain time is, let's suppose, A2, and then again here, again one more line, this A these all three areas equal each other. Okay. This is that the area covered by the planet in certain time will equal area covered by the planet in another certain area with respect to time. Okay. So this area, and this area, they equal each other no matter how wide they are from each other. They will still equal each other. That's one of the laws, which is second law of Kepler, and the laws are named as